We are going to understand the velocity time graph today. Okay, velocity time graph. So what is velocity? Velocity
Yes,
is the rate of change in displacement.
velocity,
The rate of change
change
in
in
displacement.
distance.
No. It is the rate of change in displacement. Okay. So let
The
me
rate
write
of
here.
change in displacement.
Yes. The rate of change in displacement. It's called as velocity.
Yes.
Okay. So now we are going to define velocity time graph. Okay. So I'm defining here the velocity time graph. So what will be the definition for velocity time graph?
A graph in which
Yes. The graph which is drawn with which is drawn with velocity
and time.
against time
And time.
is called as
Velocity time.
yes, velocity time graph. Velocity time graph. Understood?
Yes, sir.
Okay. So we will check first velocity time graph for uniform velocity. Okay. So first we will check now velocity time graph for uniform velocity. Uniform velocity. Okay. For uniform velocity.
Yes, sir.
Okay. So we know, like in the uniform velocity, there is no change in speed of an object. Is it or not? Is it?
Yes, sir.
Okay. So let me draw one graph over here. First, we have to write table. We have to take some values here. So here I have taken time. Again, time in second. And here I have
Velocity.
taken velocity. Yes. And velocity is meter per second. Meter per second. So
Yes,
first
sir.
I am taking 0. So it will be 0. So velocity will be 0. Now I am taking time 5 seconds, then 10 seconds, then 15 seconds, then 20 seconds, and then 25 seconds. Okay. Yes. So for like 0, not for 0, like the velocity will be like speed is not going to change. Is it? That means velocity is not going to change. So not will take non-zero here. Suppose velocity of the train. Okay. Suppose the train is traveling from again different stations. 1, 2, 3, 4, 5, 6, etc. And this is the track. And this is the track. And train is traveling from here. And we are observing from here. See, like here the velocity of train from Kolkata means Howrah station to Mumbai station. Okay. So here the velocity of train we have observed on the 0 second means at any station. So the velocity of train will be 60 kilometer per second. Again we have observed that after 5 seconds, so velocity again 60 kilometer per second, again 60 kilometer per second means velocity is not going to change. That's why it is called as uniform velocity. Is it or not?
Yes, sir.
Yes. So here again I am taking 60 kilometer per second or 60 meter per second. Again I am taking 60 meter, again 60 meter, because it's changing with the same rate. Again 60, again 60, because velocity is not going to change. Only time is going to change. Speed will remain constant, 60, 60, 60, 60. Okay. So I'm erasing that
Yes.
part. That part is not required to us. Okay. So for that we are going to draw the graph now. So let me plot the graph here. Okay. Suppose this is the x-axis and this is y-axis. Here I am taking velocity. Wait a second. Huh? Again, it is hanging. Where is the notes? Note one. Okay. Yes, Achi. Yes, you raise the hand.
Also by mistake.
Okay, okay. So here we have velocity, and velocity is going like this. And here I am taking time, and time is here. Okay. So I am taking here like 10. I'm taking 20 distance. Huh? It's 20. It is 40. It is 60. It is 80. And time here 0. Here 5 seconds. Here 10. Here 15. Here 20. Here 25. Here 30. 35. 40, etc. Okay. So see, at 0, velocity will be 0. So line point will come here. So for all the time, like we will get straight line. So I'm going to draw the straight line from here. Wait a second. Yes, we will get straight line which is parallel to x-axis. Okay. So here we have like first coordinate here, second coordinate here for 5 seconds, then 10 seconds, for 15 seconds, 20 seconds, then 25 seconds, etc. Okay. So see, all the time velocity is constant. Okay. So this is the graph for velocity time graph for uniform velocity. Okay.
Yes, sir.
Okay. So now take a screenshot. So let me write here. It is velocity time graph. We have to write scale also. So scale I'm writing here. In y-axis, it is y-axis and it is x-axis. So in y-axis, 1 centimeter equals to 20 units. And in x-axis, 1 centimeter equals to it is 5 units.
Unit.
Yes. So this is the scale. Okay. Understood, or any doubt you have here?
No, sir, understood.
Okay. Take a screenshot for that.
Sir, take a.
Okay. Any doubt?
No, sir.
Okay. So now we will check for non-uniform. Okay. So now velocity time graph for uniform acceleration. We will check first for uniform acceleration. Okay. So velocity time graph. Acceleration means the rate of change in velocity. if it is increasing like every equal interval of time, like the same thing, okay, like it is increasing every time. So it will not like 60, 60, 60. It will like 60, then 70, then 80 like this, is it? So we will draw the graph for velocity time graph for uniform acceleration. It is nothing but for the positive acceleration, rate of change in velocity, and here velocity will increase. So velocity time graph for uniform acceleration. Uniform acceleration. Okay, for uniform acceleration. So I'm taking one more data. So I'm taking one table here. Let me draw the table. Again, it is not working.
मैं ट्यूशन कैसे जाऊंगा?
Okay. So here I'm taking again time in second, and here velocity. Velocity is in meter per second. Okay, so again here first will we have 0, so velocity will be 0. Then we have suppose 5, and the velocity becomes 8. Then we have 10. At 10 second, velocity will be 16. Then we have at 15 second, it will be like 24. Uh, then 20th second, we have 32. We have like 25th, we have 40, and 25, then 30, as we have 48. If you want to take one more value, we can, or otherwise we will stop here. Like take one more value, like 35, and here we will have 56. Okay. So see, if I'll check here, the difference is 8. Again here difference is 8. So each time there is a difference of 8 unit. Means the velocity increases by 8 meter per, yes, velocity increases at the rate of 8 meter per second in every 5 seconds. We can say that, is it? Is it or not?
Yes, sir. Yes, sir.
That means it is the uniform acceleration. Okay, because the rate of change in velocity is acceleration. Yes. Okay. So let me draw the graph here. Please mute your mic. Okay. This is y-axis, and here it is x-axis. Y-axis. Okay. So here we have point 0. Here I am taking velocity. So let me write velocity here. velocity. Velocity, yes. It's very difficult to write like vertically, na?
Yes, sir.
Yes. So in this way, velocity, and here I'm like taking time. Time is in second, and velocity is in meter per second. Okay, it is unit of velocity, and unit of time is second. So it is SEC. Huh? Okay. So here again, I'm taking values like we have. Let me just take this graph aside because velocity. Okay. Here. Here we have y-axis, and here we have value 0. Here. So I'm taking at equal distance like here 8, 16, 24, 32, then we have 40, 48, and 56. So here we have 8, then we have 16, then we have 24,
24,
then we have 32,
32,
then we have 40, then we have 48,
48,
and 56.
56.
And here 1, 2, 3, 4, 5, 6, 7. Here we have 0, then we have 5 seconds, then we have 10, then we have 15, then
10.
we have 20, 25, 30, 35.
Okay, 35.
Yes. Okay. So like in first it is 8, huh? It is looking like 0, it is 8. Okay, so for our first value we have 0 and 0. So first coordinate will come here. Then we have 5 and 8. So 5 and 8. So next will be here. So we will take all the points in a straight line. So let me draw a straight line first. Okay. So here we have first point from 5 to 8. Then we have 10 to 16 here. Then we have 15 to 24 here. Again, it is hanging. Wait a second, beta. Why it is hanging? I
Yes,
don't
sir.
know. Again and again. So data is in note 1 is more. That's why I have to erase most of the classes. It's here. Okay. So here we have second point, then 15 to 24 we will have here. Then okay, all the point you will get in the same line, and when we will draw all the line we will get the straight line like this. Okay, so here it is the first we have to write scale. Here in x-axis, x-axis we have 1 centimeter equals to 1 centimeter equals to no 1 centimeter equals to, we have how much, 8 unit. Okay, or we can say 8 meter per second. That unit is nothing but 8 meter per second. Huh? And in y-axis, no, in x-axis it is 5 seconds. It is 5 seconds. And in y-axis we have 1 centimeter equals to 8 unit, and 8 unit is nothing but meter per second. Huh? Okay, so this is all about the scale. So here we have got the positive slope. Okay. Here we have got the positive slope. So I am writing here positive slope shows that you there, beta?
Yes, sir. I'm there.
Okay. So what positive slope shows that? Uniform acceleration, huh?
Yes,
Uniform
sir.
acceleration. Okay. So this is all about the velocity time graph for uniform acceleration. Now take a screenshot for that.
Sir, taken.
Okay. So any doubt beta here?
No, sir.
Sure? Pakka?
Yes, sir.
Okay.